Alright, Mr. Wynn here, talking about Learning Target 2. Learning Target 2 is I can describe the different properties of water. Now, as you can see here, I have some sugar, I have a cup of water, and I have ice. Now, the first question states, allow substances like sugar and salt to dissolve in water. Okay, so if I were wanting to demonstrate that substances like sugar and salt dissolve in water, what I'm going to do is I'm going to pour this in. As you can see the molecules of sugar. Okay, it's really cloudy, and if you mix it up, you can pretty much see that the particles of sugar are starting to dissolve. So if you mix this even more and more and more, eventually that's going to turn clear, because water is a universal solvent. Okay, so what it means to be a universal solvent is that substances like sugar will dissolve in water. Now, so that's the answer for number 1. Allow substances like sugar and salt to dissolve in water. Explains why we are tired when we are sick. So, water requires a lot of energy in order to change its temperature. So if it requires a lot of energy to change its temperature, that must mean that we're going to be really tired whenever we get sick. Because whenever we have a fever, we have to increase our temperature, and by increasing our temperature, we're expending a lot of energy. Now, allows organisms, and the answer to that one's going to be high specific heat. Now, allows organisms to walk on water. Now, on the other video, I show you surface tension, I show you adhesion and cohesion. So in this instance here, where allows organisms to walk on water, we're going to be talking about cohesion, and we're going to be talking about surface tension. So the bonding of like molecules, such as water molecules, are going to allow organisms that are lighter than water to be able to walk on top of it. Water is denser as a liquid than as a solid. So that's the reason why I have a cup of ice. Now, if we were to put ice into water, okay, we notice that it floats. Now, why is this biologically important? Well, the reason why is because water as a liquid is denser than the solid water, or ice. So this is important biologically, because during wintertime, whenever we have lakes freezing over, lakes aren't going to entirely freeze all the way through. So organisms in lakes, in rivers, and in different types of in different oceans, they're going to be safe, because water is going to be able to retain the heat at the bottom of the different types of bodies of water. So those are the different properties of water. Now, I want to talk about hydrophobic versus hydrophilic. Now, if you break those two words down, okay, so hydrophobic means water fearing. Hydrophilic means water loving. Okay, so of course, just like a phobia, this is fear, and philia, okay, is going to be love. It's Latin for love. Okay, so we're going to have water fearing and water loving. Now, generally, things that are hydrophobic are also going to be nonpolar. And then things that are hydrophilic are going to be polar. Now, if you recall what polar and nonpolar means, polar means that you're going to have uneven charges of molecules, or actually uneven charges of atoms within a molecule, whereas a nonpolar, you're going to have even charges found throughout the molecule. So an example of this would be something along the lines of, if you were to have a nonpolar, it would be C, H, 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 and H. So you can see that these H's here pull the same amount of force on this carbon, and these are going to pull the same amount of force on these carbons. So you're not going to have any differences in terms of charges. Now for a polar molecule, let's say for instance we have water. Oxygen is very, very large compared to hydrogen. So if oxygen is very, very large compared to hydrogen, it's going to pull more on the electrons than hydrogen does. Because remember, this is going to be a covalent bond. With the covalent bonds, they're going to be sharing 2 electrons between these 2 hydrogens. So 2 electrons here and 2 electrons here. Oxygen is much larger than hydrogen, so if it's going to pull harder, it's going to be more electronegative, so therefore it's going to carry an overall negative charge. So if this makes this negative, then this has to be positive. Now explain condensation and hydrolysis reaction. So whenever we look at hydrolysis and we look at condensation reaction, we have to think about 2 things. First of all, what is the role of water during condensation reaction, and what is the role of water during hydrolysis? So the role of water during condensation reaction is going to be that it's going to join molecules together. Now the role of hydrolysis is, the role of water in hydrolysis is that it's going to split apart molecules. So if you were to look at this formula here, the first question you want to ask yourself is, are we building up a molecule or are we breaking it apart? So you look at carbon dioxide plus water and energy makes glucose, and it makes 6 molecules of oxygen. So in other words, this is photosynthesis. So in this instance here, we're taking 6 molecules of CO2, we're taking 6 molecules of water, and we're making glucose. Now we know that CO2 and glucose compared to CO2 and water compared to glucose are much smaller molecules. So in this instance here, we have 2 small molecules building up a larger molecule. So this must be a condensation reaction. Okay. Number 4, we've already drawn the water molecule and shown its polarity, which is going to be that one here, where again the hydrogens are going to be positive and the oxygens are going to be negative due to the size of both the atoms. And then the last one, explain how cohesion and adhesion were demonstrated in the Penny lab. So I again have attached a separate video to show what would happen if you put drops of water on the Penny, and explaining both cohesion and adhesion. So if you have any questions about Learning Target 2, please don't hesitate to ask. Thanks for watching.